Hey guys, welcome to section 2, chapter 7 of the Algebra 1 program. And in this section, you're going to learn your second tool in order to be able to solve systems of equations. So last section, we talked about what systems of equations were, a set of multiple solutions with which you needed to evaluate something. We learned that the first way that we could do that was by graphing. And that just piggybacked off of what we did the previous chapter. Hopefully that went smoothly, and all you needed to do was find the point of intersection. Remember, if there was no intersection, then there was no solution. And if you ended up with the same line, there was an infinite amount of solutions. Okay? So today you learn the second tool. And the second tool is going to be solving by substitution. And again, this method should be a little bit familiar because we have been doing types of substitutions in our equations all year. So what will be different is that we're not substituting just a single value, we're actually substituting an equation. So without further ado, let's jump right in. All right, so let's say we have the systems of equations y equals x plus 4 and y equals 3x. So when we mean substitute, we're actually going to do a replacement. And with this first example, I tried to make it very easy. We already have our equation solved for y. So I simply need to grab one of the equivalent values and make the replacement in the opposite equation. Now, I want to be clear, as I'm working through these examples, there will often be multiple ways that you can solve these in terms of the order with which you maneuver the terms, what you solve for first, and even what you replace. There's a lot of options here. I'm going to choose one, or what I think is probably the simplest, but as long as you're following your algebra rules, we should all get to the same answer. So feel free to use your instincts in solving these. Just make sure that you're following all the algebraic operations. So for this one, it seems to me that substituting the 3x into the first equation would be the easiest. So I'm going to do that. So instead of writing that first equation with y, now I'm going to write it with 3x equals x plus 4. Again, notice here I put this 3x in for y and rewrote it. And of course, the reason we do this is because we can only solve for one variable at a time. So I need to make sure that this equation only has one variable. And now I can get all of my x's on the same side, and x will equal 2. Now you're not done. Don't get comfortable, right? Because when we solve systems of equations, our answer is a point in xy form. This is our solution, right? So if my solution doesn't look like x comma y, then you haven't generated the solution yet. We've only generated part of it. Okay, so I have my x equals 2. I can substitute that back in to either equation. So if you wanted to substitute it into this equation, you could, or you could substitute it into that one. I choose to pick, I would say, what looks like the easiest sometimes, or maybe the top. In this case, I think maybe the bottom, I don't know. But either way, we're going to get the same answer, because y should equal 6. Notice if this is my second equation, if I had put it into the first equation, I would have gotten 2 plus 4, which is also 6, right? So it doesn't matter which one you substitute. Again, as long as you're following your algebra rules, you're good to go. So my solution is x, which is 2, comma 6. Let's do another one. Let's say we have this system, x equals negative 2y plus 1, and x equals y minus 5. Okay, I need to make a replacement. Both equations are solved for x. So I'm going to take the second value for x and plug it into the first equation. Remember that you're always taking a part of one equation and putting it into the other. That's why you need both. Okay, so when I rewrite this, I'm going to get y minus 5 equals negative 2y plus 1. If you're having a hard time seeing the replacements as we move through this, I encourage you to pause the video and take a little bit of time to kind of process it. Because once we make the substitution here, I'm hoping that your great algebra skills are going to let you just fly here, and we'll be able to quickly start to solve these things. So obviously now I'm solving for y. This is going to be 6, and y is going to equal 2. Now again, you're not done, right? You have to make a substitution. So I would go back over here and do x equals 2 minus 5, and x is going to equal negative 3. So my solution, don't forget this part, is negative 3, comma 2. All right. I'm going to keep cruising, but please stop the video if at any point if I'm moving too fast. I want to do several example types for you. All right, so let's do one where the equations aren't solved for a variable. So for example, what if we have the system 3x minus 2y equals 0 and x plus y equals negative 5? Okay, the first two equations were easier because they were solved for either x or y, and we could make the substitution right away. Well, in this case, neither one is solved. So we have to solve for one of the variables first before we can make the substitution. Now, the first equation looks like it's going to have more steps than the second equation. So I'm going to choose this second equation here, if I label them 1, 2, and I'm going to solve this one for y, I suppose. You could solve it for x and make the replacement for x. That's totally fine. But I'm going to solve this one for y. So if I solve this second equation for y, it means I'm subtracting x from both sides, and I'm going to get negative x minus 5. Now, I'm going to rewrite this for clarity's sake here so you can see what I'm doing. So I keep my top equation. I haven't done anything to that guy. But now I'm going to bring in this bottom one that I just rewrote. Okay, I didn't solve for any number value or any solution. I simply rearranged the equation and solved it for y so that I could make a substitution. Okay, so now I'm going to take this value and substitute it in for y. All right, rewriting my equation then becomes 3x minus 2 times the quantity negative x minus 5. Remember we taught you that anytime you make a substitution here, we should use parentheses? Well, that's still going to be the case. So make sure when you're making this multi-term substitution that you get those parentheses in there, because we're going to have to distribute that too. So now as we solve, remember the distributive property? I'm going to get negative 2 times negative x, which is a positive 2x. Negative 2 times a negative 5, which is 10. That equals 0. Okay, so now I'm going to combine like terms here, and I'm going to get 5x equals 0 minus 10, which is a negative 10. Divide both sides by 5, and x is going to be negative 2. Now, we have to substitute the x back in. And people are always like, where do I substitute it? You literally can substitute it here. You can substitute it here. Or you can substitute it there. Any one of those is going to give you the answer that you need for y. A couple of them will require a little bit more work, but you will absolutely get there. However, this last equation here, we'll call it 3, seems like it would require the least amount of work. So y equals negative 2 minus 5. So y is going to equal 2 minus 5, and y equals negative 3. So our solution is going to be negative 2, negative 3. Okay, I want to take a second and remind you something that you're going to work on in this section a little bit too, is how can you check to see if your solution is correct? We do all of this work, and sometimes the numbers look really good, they feel good, But how do we know if our solution is actually the solution to these equations? Well, all I need to do is substitute them back in and see if the answer is true. All right, so I'm going to do that for you with our solution here. So in my first equation, so this is our check. You have 3 times x, remember this is our solution, so I'm going to make my substitution here for x, minus 2 times y, my substitution is y, should be 0. So I get negative 6 plus 6 equals 0, 0 equals 0, that checks. Okay, what about in our second equation? This is my first equation, my second equation, negative 2 plus negative 3 should be negative 5. Well, sure enough, negative 5 is negative 5. It checks out. So when your solution works in both equations, you know you've gotten it. Okay, let me show you a couple of special cases. All right, what happens if you have this system, 6x minus 3y equals 6, and y equals 2x plus 5. All right, this one we're feeling good because one of the equations is solved for y. So I can take that value and substitute it for y in the first equation. When I do that, I generate this equation, 6x minus 3 times 2x plus 5 equals 6. Notice I'm taking it and replacing y. All right, now I need to distribute the 3. So 6x minus 6x minus 15 equals 6. Now when I start to solve this, look at what happens. Those 6x's go away and I'm left with negative 15 equals 6. However, is that a true statement? No. So when you get a situation where your variables drop out and you get an untrue statement, then it's no solution. So when your variables drop out and it's an untrue statement, then it's no solution. In contrast to that, what if we had this system 2x plus 3y equals 8 and 3/2 y equals 4 minus x? Ooh, this one's so nice. I got a little fraction in there. Don't you guys love that? Okay, so we can deal with the fraction if you want, or in this case, it might be easier to solve the second equation for x. Why don't we do that? So if we're going to solve the second equation for x, maybe the first thing I want to do is add x to both sides so it's not negative. So you're going to get x plus 3/2 y equals 4. And then I'm going to subtract 3/2 x from, or 3/2 y from both sides. All right, so what we have now is a substitution for x. So I'm going to take this. This is for my second equation. And I need to put it in for x in the first equation. Make sure you take that negative with you. So when I rewrite, I'm going to get 2 times the quantity, negative 3/2 y plus 4 plus 3y equals 8. All right, so when we have 2, now we distribute, right? So 2 times a negative 2/3, those 2's go away, and I get negative 3y. And I still do need to distribute that too. 2 times 4 is 8, plus 3y equals 8. Now these 3y's go away, and I get 8 equals 8. So in this case, my variables disappeared, but I'm left with a true statement. In this case, there is an infinite amount of solutions. So notice the difference. In the first case, you had an untrue statement with the variables dropping out. In this case, you have a true statement with the variables dropping out. And that's going to be the difference for you. Okay, make sure you go back through these examples, go slowly. Make sure you can see the replacement. We're going to practice this a ton over the next 2 weeks. So if you're feeling pretty shaky about it now, hang with it. We're going to get lots and lots of practice, and hopefully you'll be feeling good. Just remember, the essence of this is that we're solving for one variable so that we can make a substitution in the other equation. And hopefully you'll be all right. So take your time, finish up your notes, read through the section, and begin your assignment.